Just to briefly summarize how I ended up here, I mean, as a student, I studied mathematics, and I became very fascinated by the mathematics underlying cryptography and information security. And while I was studying this at Oxford, my supervisor said, you know, the physicists say they can break the stuff you're working on. And so, of course, I said, well, they don't know what they're talking about, and tried to ignore it. But then I realized they were right, and it was really a matter of when and not if. So I switched to quantum computing and started working on the foundations of what is possible and not possible in this emerging technological environment. And in recent years, I've returned to my roots, because I've become profoundly concerned that we're going to lose the race. We're not going to prepare our infrastructure to be safe in a world with quantum computers before quantum computers are here. So that's what I've realigned my entire research effort on, as well as all my proselytization and interactions with industry and government now. So if we could... technology continues to enable capabilities we previously hadn't even imagined. Okay? From wireless communication to computation to the internet, and now as we move forward to artificial intelligence, the Internet of Everything, and so on. There's another massive array of technologies coming as we move from being spectators of quantum mechanics to actually being able to play, the game, become active players. So what is quantum mechanics? Well, it's ultimately just a language. It's a mathematical language that lets us talk about a particle being here and there at the same time. Or an electron in one of those little loops you see up there in the diagram, spinning around clockwise or counterclockwise at the same time, whatever that means. Okay. This is called quantum superposition. And the implications for computation are that, whereas today's computers, deep down in the guts of a computer, there's an array of bits that can each store a 0 or a 1. A quantum computer can explore countless configurations of zeros and ones all at the same time in some meaningful way, and solve problems we previously thought we could never solve. So harnessing quantum physics and a host of new technologies is going to bring very exciting opportunities. And again, we're not talking about a new app. We're talking about a new foundation for what is actually possible. So what are some things we believe we know are going to be possible? Well, for one, quantum bits are very fragile. They're tremendously sensitive. So that means they make great sensors. They can be used to discover and develop and commercialize an array of new sensing technologies, whether it's for medical imaging, detecting dangerous substances, and so on. That's going to be the first generation of what these quantum technologies will offer us. Quantum bits also have the property that if you snoop on them, you must disturb them. That's another very fascinating, novel property of matter, which is a wonderful new tool for those of us trying to develop to protect against hackers and adversaries. So it's a great tool for cryptography, privacy, and cybersecurity. This massive parallelization I told us about earlier, right, allow us to solve all sorts of computational problems that previously we simply dismissed as infeasible in the lifetime of the universe. So we can now explore the properties of exotic new states of matter and perhaps develop materials that can capture and transmit energy with massively less loss of energy. Or design new drugs that otherwise we wouldn't be able to optimize or design. Or optimize the production of fertilizers in a way that is much less wasteful. Or optimize the design of buildings, systems, or the allocation of resources, and so on. Now, the truth of the matter is, just as we had no clue what computers and wireless communication and the internet would be used for when they first emerged, we are certainly only scratching the surface for what this entirely new technological platform will bring the world. Now, as more and more of our lives become intrinsically linked to cyber technology, so most technologies are somehow connected to cyber in one way or another. At the same time, the flip side, the shadow side of that, is we are currently witnessing an unprecedented level of vulnerability. Okay? Hackers can now attack us. They can attack countless systems at lightning speeds remotely. That's an unprecedented level of vulnerability. Okay? Even if hypothetically, today's systems were secure against the known threats, and they're not, then as new technologies and capabilities emerge, then there's always the possibility that the new unknown unknowns will emerge. Furthermore, it turns out that while my colleagues and I are pursuing quantum computing and quantum technologies for all the wonderful things that will bring the world, one of my colleagues, Peter Shor, when he was at AT&T in 1994, discovered that these quantum computers will break the foundations of our cryptographic infrastructure, or one of the core pieces known as public key cryptography. And the reason is, the reason our internet, our mobile phones, and so on are secure today, because a problem like this, consisting of, I give you a large number, please find its prime factors, on a conventional device, if the number's large enough, we think that's infeasible. You can never solve that, at least certainly not in a reasonable amount of time. However, with quantum computers, this problem becomes really, really easy. Now, fortunately, Peter discovered this in 1994, before we had the devices. So we've had plenty of time to protect ourselves against it. Okay. And again, it's important to note, this is not some esoteric risk. This is at the foundation of our ICT infrastructure. Okay, this is how we protect anything connected to the internet from being hacked. This is how we know that the software we're downloading all the time automatically is actually authentic and not malware. Right? And otherwise, we'd lose control of our devices. This is how we know that our information, whether it's health information, financial information, state secrets, trade secrets, that when it's being encrypted, it stays encrypted. So it's critical, like in order for the arrival of a quantum computer to be a positive milestone in human history, we have to first mitigate the risks that we know it brings. This is not an unknown unknown. We know this is what will happen when a quantum computer comes. These specific tools that we depend on immensely will be broken. And again, we're not talking about patching something like Heartbleed. Okay, that's a very, that's just a problem that can be quickly patched once you discover it. There'll be a lot of bleeding, but at least you can stop the bleeding and move on after. We're talking about an unprecedented, profound systemic risk. And it's important to understand that rebuilding the entire mathematical foundations of cryptography takes decades. It's not a software patch that you can deploy in a couple days. So we need to defy human instinct. We have to find a way to defy our human instincts and the usual human patterns, which is to just get excited by the new tools and the capabilities and to focus on reducing cost, greater speed, grabbing as much market share as possible, and worrying about security later when we essentially have no other choice, when a catastrophe happens or it's looming us in the face. It's looming imminently. We have to somehow bypass that because we won't have time to recover. We can't wait for the cyber Pearl Harbor and then have the political and business will to do something about it, because it takes decades to do something about it. Now, there are signs of hope. Okay? I don't want to overstate them, I don't want to understate them, but some major world governments have finally come out and said, this is important, we're going to do something about it. To do business with us, you're going to start to use, in the near future, which means many years, codes that will be resilient to this next generation technology. Major standards bodies are starting to work on this. Major companies are starting to look at this in their research labs. It's a good start, okay? But much, much more needs to be done to mobilize the large base of cybersecurity users, vendors, policymakers, to make sure to make the best use of the remaining time we have. So how much time do we have anyway? I get asked this all the time, right? And if you read some articles, it sounds like you have about 6 months, okay? Well, no, those are different kinds of quantum computers people are talking about, not ones that we know that we believe can threaten cybersecurity. So in 2015, I started publicly posting my predictions. And then I said, look, there's a 1 in 7 chance that by 2026, these key ciphers will be broken. Which is, probably not. But 1 in 7 is a significant chance given what's at stake. And by 2031, I was taking even money bets. A bottle of scotch for a bottle of scotch, that it'll happen by 2031. Okay? So that's, to most people, they're like, oh, so I can wait. Well, no, because you have to cross that finish line. You have a long race ahead of you to cross that finish line to actually be secure against that threat. Again, this is not a quick patch-up job. So what we want is the following, okay? Of course, we want to avoid the collapse of our IT infrastructure, right? We don't want it to collapse, and there's no fix available, so what are we going to do for a few years without an internet, right? And everything else that depends on it. That would be catastrophic, but that's not enough. We don't want some last-minute heroic effort to save something we should have prevented in the first place. Because if you do that, then the very foundations of our entire cyber infrastructure are going to be tremendously weak. Because when you rush, you're going to make tons of mistakes, tons of bugs, and you're going to get tons of heartbleed type vulnerabilities going forward. And that'll be the best you can hope for, right? Because when you build something, right, on a very flimsy, flammable foundation, you know it's going to hurt. You know it's going to be a problem. The best you can hope for is something very unreliable and dangerous. Right? We have an opportunity, an unprecedented opportunity. Because if we didn't have this threat, we'd probably keep plugging along with this very mediocre infrastructure we have. We now have a perfect reason to make the very foundations of our cyber infrastructure more secure than it ever was and ever would have been. So we need to take advantage of that. So I'm going to make an aspirational, and some might say delusional or optimistic, but let's say aspirational prediction, right? That not only will we protect our cyber systems before quantum computers become a reality, but we'll have done it in an open, transparent, careful, and disciplined way. So the net result will be a cryptographic foundation that is much stronger than the current one, and will give us much more reliable building blocks, right, filled with many, so we'll have a much more reliable future filled with many new and unexpected technologies. Again, much safer than it otherwise would have been. And we can then safely embrace all the positive applications that quantum technology will also bring. Now, this does require your help. So I always assign homework, right? We need everybody's help here. Whenever you get a chance, these are the small steps. This really requires a very broad grassroots movement to stimulate the business and political will to do something. Okay? So whenever you get a chance, we need you to ask your vendors. So what is your quantum plan? Very nicely, right? But what is your quantum plan? Because they won't prepare the solutions unless their customers are asking for it. So we need to start asking more and more the question, right? And policymakers. And within your own organization, your IT people, your own risk managers, ask them, like, what is our plan? And if everyone starts articulating their plans, we can cross-reference, see what the dependencies are. Because I think a lot of people, this human nature, we're assuming someone else is going to fix the problem for us. Now, maybe they will. But let's just ask. Let's just maybe, before we waste 20 years assuming someone else is going to save us, let's just ask. And I think inevitably, the simple, very cheap exercise of asking for each other's plans, articulate what is our risk and what are we going to do about it over the next 10 years, that'll be an important first step that we need everyone to engage in. So thanks so much for your attention. Please don't hesitate to reach out to me. I'm happy to discuss any questions about quantum computing, quantum technology, cybersecurity. It'd be a great pleasure. So thanks again for your attention.